In this chapter, we're going to look at the code that is used to create the CRUD application. And this is the PDO version of the CRUD application. This is the version that I intended to write. This is the version that I will continue to maintain. And this uses the PDO interface in PHP. If you want a little tour around the CRUD application, look at the intro movie for the MySQL.avi version in the last chapter. This is the CRUD application, and this is the CRUD code. And it's written in PHP, and it uses the PDO interface to the MySQL database. So let's go ahead and get started and start looking at the code. So this is the initialization code in the CRUD application using the PDO interface. The PDO interface is the one that I chose for this application, so this is the code that I actually use and maintain. Here's where the connection to the database happens, and it's a little bit more complicated, a little bit different than the interface from the MySQL.avi interface. It creates a new PDO object using the new, and it names that object DBH, which is the traditional name for a database handle. And it uses this string for initializing the database. This is a carryover from the Perl interface that PDO is based upon. It's called DBI in Perl. It's very common, very popular. And it works with multiple different databases here. So you specify which database you're using. In this case, it's MySQL. This will work with Postgres or with Oracle or Microsoft SQL Server or all kinds of different databases using the same code. You specify your host, you specify your database name, and we use the constant MySQL DB from that that's initialized at the top of the code. And your username and password that are also constants initialized at the top of the code. And here we specify that we're going to use the persistent connections. So persistent connections are a valuable feature, and here's what a persistent connection is. Whenever somebody clicks on a web page, or they move from one page to another within the same site and within the same session, that click creates a whole new connection between the web browser and the web server. Now, under normal circumstances, that would create a new instance of your program. Your program would have to set up its database connections and then destroy the database connections at the end of the program, which is just when they click on another page. Now, this is resource intensive. It uses a lot of resources to create and destroy all of these database connections, which slows things down and makes things seem sluggish. So instead, with a persistent connection, what happens is that the web server manages a pool of connections. And every time somebody clicks on a page, one of those connections can be reused. It's handed off to the program. They can use that existing connection, and then the connection goes back in the pool when they're done with it. This saves time, it saves resources, it makes your application feel snappier to the user, and it improves the user experience. So we're using these persistent connections, and PDO makes these persistent connections readily available without depending upon a particular driver for MySQL or for whatever database. So this is how the database connection is created, and it's very simple. This is the simple code in the initialization section of the CRUD application using PHP and MySQL. This is the update album SQL function, which updates the album table in the album database. You notice the SQL here, update album, set, title equals question mark, artist equals question mark, etc. The question marks are replaced with actual values later on. This is called a prepared statement, and it uses these tokens and allows the execute statement later to replace the tokens with the actual values. That way the system can quote them properly and it can format them properly for the SQL without you having to decipher, is this an integer, is this a string? It allows this all to happen automatically. So it's less prone to error, it's less prone to crashing, and it's less prone to problems in general. It also allows you under different circumstances to prepare one statement once and to execute it with a different set of values over and over and over again, which can be another type of inefficiency. So this function uses prepared statements, and we use prepared statements wherever possible throughout this code. So let's talk about how we fetch data from the database using PDO in PHP with MySQL. This is the getAlbumsSQL function. It's very simple. All it does is it executes a query and it returns a handle to that query statement, the statement handle. The query is simple. Select star from album, order by title, and that gets prepared and executed. And what gets returned is called a statement handle. This statement handle represents the data, but it doesn't actually contain the data. With a statement like this, select star from, you could end up with a lot of data, depending on how many albums are in the database or how many tracks are in the database. If we were doing this with the tracks, you could easily fill up memory in the server, and you don't want to do that. Instead, what you want to do is you want to be able to execute that query and then take the results one by one. And so that's what this does. This returns a statement handle, which represents a pointer into those result sets. And then way up here, where this gets called, under list albums, the first thing it does is it calls that get albums SQL, and it takes that statement handle and it starts fetching rows. It fetches the first row separately, and it fetches it using this fetch associative flag, so that the row variable is an associative array where each of the column names are key names in the associative array. So now you know the names of the columns. And then down here, in this block of code, we actually loop through, grabbing the result rows one at a time and building them onto the screen using this album result row function, which actually builds the HTML to put it up on the screen. So this is the efficient way to do this, and it's the safe way to do this, where you execute the query once, and that sets up the interface to start returning result rows, and then you grab the result rows one at a time out of the database rather than collecting them all in memory and potentially having a problem with crashing the program. So this is how you fetch results from a database using PDO and PHP in MySQL. Let's take a look at how you insert data into a table that has an auto increment ID field. This is the insert album SQL function, which inserts data into the album table. And here's the SQL, insert into album, title, artist, label, released. And it's a prepared statement like we've seen before with the replacement parameters. But the interesting thing here is how the ID field is handled. You'll notice that we don't specify it, we don't insert a value, and that's correct because it's automatically generated by MySQL when the data is inserted into the table. But it becomes available in this function called last insert ID. And so we're able to access it because we actually need it to be able to tie other data together using that ID field. That's an important piece of our join tables. And so we're able to access that and return the value in this ID variable. So it's as simple as that. This is how you insert data into a table that has an auto increment ID. You're able to access that value with the last insert ID function, and this function here returns the value in the ID variable.